Hello, my name's Julian Edgar and I'm the author of the book you see in front of you, Car Electrical and Electronic Systems. What I want to do in today's video is talk about the idea of input impedance. Input what? Sounds really complicated, doesn't it? But it's not. It's actually really straightforward. It's also responsible for some of the confusion that people get into when they don't understand what it really is and they apply sort of their own logic to the way things should work and they don't work in that way. So let's take a look at input impedance. Now we're going to start off with the simplest possible circuit, 12 volt battery and a light which is switched on because the circuit is complete. Now, what current and what resistance are occurring in this circuit? Let's take a look. Let's say the resistance is exactly as the name suggests, it resists the flow of electricity. Let's say the resistance of the light bulb is 3 ohms. Now, how much current, how much amps are flowing? Well, 12 volts divided by 3 ohms gives us 4 amps. And so we know there must be 4 amps flowing in that circuit. If the light bulb posed a resistance of only 2 ohms, it would be 12 divided by 2 equals 6 amps. So you can see the magnitude of the resistance determines for a given voltage how much current is actually flowing. Easy, isn't it? Now, what happens if we connect a multimeter across that 12 volt battery? How many amps are going to be flowing in that circuit? Well, in the case of the multimeter, something like this, 0.0000012 amps. So the tiniest possible current. Now, why is that so? I hope you realize it's because the resistance posed by the multimeter must be very, very high. And in fact, if we have a look, it's 10 million ohms. 10 megohms is typically the input impedance. There's that term, the input impedance of a multimeter. Now let's take a look at why that's important. Very little current flows, so it doesn't load the circuit down. So even if that 12 volt battery were nearly flat, its voltage wouldn't drop any further when we connected the meter. Why? Because the meter is drawing such a small amount of current. Now, the other way of looking at that is very little current is passing through the meter. And some people will say, oh, but you're just connecting it across the battery. That's a short circuit across the battery, isn't it? Won't the current destroy the meter? And of course it doesn't, because the input impedance of the meter is so high. So what other devices have high input impedance? Well, we've seen the multimeter. All modern digital multimeters have a very high input impedance. Older analog ones have much lower input impedance and can load circuits down. But what about if we're connecting a signal, say, to a programmable ECU? Here we have a Haltech ECU. It has high input impedance on its inputs. So if we wanted to monitor battery voltage, we could just connect 12 volts straight to one of its analog inputs. If we wanted to monitor the voltage coming from another signal, another sensor, we could just connect it straight to it. Very little current flows in the circuit because it's got high input impedance. I remember reading a few years ago someone saying, well, you just couldn't connect the input to the battery, would you? It would destroy it. Don't you have to put a resistor in? The resistor is built inside the unit. It acts as if it has a high resistance because of the way in which it's sensing that signal. And also something like an Arduino has high input impedance on both its analog and its digital inputs. Now, you've still got to watch the voltages. So for example, the Arduino is not happy with a 12 volt signal going in. It has a maximum of 5 volts, but you don't have to worry about limiting the current because the high input impedance of the device does that automatically. It means very little current flows, which also means you don't load the circuit down. So input impedance is just a case of Ohm's law where there's a high resistance in the device into which you are feeding that voltage. The book's called Car Electrical and Electronic Systems. Thanks for watching.